Hello, everyone. Welcome to our event of InnoWise Scale Competition to find innovative solutions for water scarcity in Southern Europe. My name is Eva Anyadi. I work for EIT Climate Kick, and I'm a water scarcity project manager at EIT Climate Kick, working on this project with a number of my colleagues. In this presentation, in this initial presentation, I will describe the agenda for today. I will give a background about this project, the Water Scarcity in Southern Europe project, placing it within the wider context of the EIT activities, and also give a description about the participants of the competition and the other elements of our project. After my initial presentation, you will hear an interview with Thomas Seidetaris, a chemical engineer from the Municipal Water Supply and Storage Company of Filaia Horiarty. And this interview will be conducted by our lovely colleague Lydia Papadaki, who is a project manager of the EIT Climate Kick Hub in Greece. The interview will be followed by two keynote presentations. The first one by Professor Phoebe Konduri, who will talk about the challenge of water scarcity in Europe. And after Professor Phoebe Konduri, we will listen to Professor Chrissy Laspidou, who will talk about innovations in the utility sector to cope with water scarcity. The keynote presentations will be followed by 4-minute pitch presentations by the scale-ups who take part in the competition today, with a very short Q&A session. This pitching session will allow the jury to score the competition presentations and come up with the final selection of the winners of this competition. The jury is comprised by 4 members, Professor Phoebe Chrissy Laspidou, Professor of University of Thessaly and Vice President of Research and Technology at Water Europe, Dr. Gianluigi Musico, Research Associate and Project Manager at the University of Campania, Luigi Vanvitelli in Italy, Dr. Eleni Toli, a Research Associate and Project Manager at Athena Research Center in Greece, and Ortwin Deroux, Manager of Business Development from Belgium, the Water Group. After the jury deliberation, we will all return to the common room and we will award the prizes for the winners. And as I said, I would like to begin with placing the project within the EIT activities. The European Institute of Innovation and Technology, or by short EIT, drives innovation in Europe by enhancing Europe's innovation capacity, competitiveness, and quality of life, creating innovation ecosystems to increase cooperation and integration between business, education, research across Europe, and address societal challenges. The EIT community is comprised by 8 knowledge and innovation communities. You can see my name ends with a KIC. That means Knowledge and Innovation Community. And I work for one of the first KICs, which relates to climate change. So we try to solve the different challenges related to climate change through system innovation. But there are other knowledge and innovation communities, for example, EIT Digital, EIT Food, EIT Health, energy, manufacturing, raw materials, and urban mobility, who all work on specific challenges across Europe with a large community of innovators. This project is managed and led by several of these innovation communities. It is led by EIT Food, who is represented by Carmen Galindo today, but also we have EIT Digital, EIT Manufacturing, and 2 external participants, Athena Research Center and Biosul from Spain. The goals of this project, focusing on water scarcity in Southern Europe, is to create awareness about water scarcity, to foster innovation related to efficient water management, to build and transfer knowledge across the different actors in this field, and to become an agent of change. We also want to implement a water saving culture within Southern Europe. And how do we do that? Within this project, in this instance, we are participating in a competition where we, through a competitive call, selected 3 problem holders across Southern Europe. And the problem holders of today's competition is the water and sewage company of Filaya Horiarty, or DEA for short, and 6 scale-ups who are working on disruptive new technologies that can offer problem holders a solution to their challenges. The specific challenges that our problem holder faces today are related to digitization of different tools, water quality and safety, pollutant traceability and removal, and asset management. You will hear more about how the scale-ups, Nanoplasmas, Engine, Shipe, Fibson, and Biodiagnostics, and Drupal set out to find solutions to the challenges faced by DEIAP. During the interview with Thomas, you will also hear from his perspective what are the specific challenges that he's facing and what kind of different solution he has been already exploring and what are the future challenges in this sector from him. And during the pitch presentations, the jury members will also have the opportunity to ask specific questions from the scale-up, so they can already give a much more tailored opportunity to solve challenges related to water scarcity. In this competition today, there are 3 very convenient prizes for the scale-ups. The first scale-up, we receive 10,000 cash equity-free prize. The second scale-up, we receive 12,000 euros of equity-free cash. And we will also have a special prize of a value of 30,000 euros for 1 scale-up only who will work next year through a demo case with DEIAP, with Thomas. And these 3 prizes will be all announced later today. So we are very much looking forward to the pitching presentations from all the scale-ups. And of course, these scale-ups have been receiving other support through the program. So they have been working from April onwards with Thomas, understanding the specific challenges he faces, but they also received mentoring and training through the program. They have been working with their assigned mentors. Each of them have been matched with 1 water scarcity expert who could help their business planning to achieve a major impact. And I would like to call out their names because they have been very much holding the hands of these scale-ups and trying to scale up their ambition and try to tailor their solutions the best way possible. So I would like to call out the names of Clyde Hutchinson, Ephimios Kaliampakas, Marco de la Velde, Pieter de Jong, Tony Conola, and Zita Dibati. I would like to thank them all for the wonderful support they provided our scale-ups, and today we can really see the results of this relationship between the scale-ups, and hopefully they will be supporting the scale-ups, and the learnings they gathered through this couple of months will follow them along their career in water scarcity. After our event, this is the first event of a series of 3 competitions. We will share, and you could have seen in the invitation in the registration page that there are 2 other competitions where we would very much like to invite you all to join, where we were looking to finding innovative solutions to the specific challenges of water utility and infrastructure company in Italy, CHIP, and the last competition will be focused around water use in agriculture, finding solutions for the challenges faced by Sanlúcar, a Spanish agriculture production company. And as I said, all these competitions and the InnoWise Scale activities are embedded in a larger program where we also work with creation of knowledge through a group of experts. We have a follow-on activity called Water Academy, where we will have technical seminars delivered by top-class experts. And we have a follow-on activities around raising awareness about water scarcity. And with that, I would like to initiate the event of today, wish the best of luck for the scale-ups, and appreciate the presence of our jury members, the keynote speakers, and all the participants. Thank you.
Thank you a lot, Eva. And now it's our turn to welcome Mr. Thormas Aitaridis, who is a chemical engineer, and he is also our challenge owner, representing the municipal water supply and sewage company of Pylea Choriati. Welcome, Mr. Aitaridis.
Hello, everyone. I would say I'm blessed that I'm participating in InnoWise Scale. It was really a breakthrough for me, and it was really innovative challenge to participate in InnoWise Scale.
So I would like to address you a few questions that are also interesting for our panel today. First of all, how does water scarcity impact your sector?
How water scarcity impacts our sector. Being undervalued, water is a resource here in Greece and in many other countries that was treated very badly. Like Hardin described in his tragedy of the commons theory. Water scarcity is pretty much the effect of such a behavior, but also a result of climate change and water uses. For instance, with a water-intensive industry here in Greece that is agriculture, we can imagine how water scarcity might affect the price and availability of, for example, rice or corn or even bread, energy production and then transportation, and even, for one example I have in mind, the microchip industry. Furthermore, it affects the quality of the water distributed, because if you have intensive like agricultural industrial uses, then here is where is the beginning of a vicious circle where solutions aren't easy to implement. So water scarcity is a daily problem here in Greece and also in our authority.
Very well. So what do you think about the evolution of water scarcity over time?
I think that we have been making the same mistakes for 40 years here in Greece. We took water for granted. Water sources are also affected, as I explained earlier, by climate change, but due mostly to bad use for agricultural and industrial uses. Greece consumes the greatest amount of water for agriculture and also has a very high rate of about 180 liters per capita every day. It's a very higher than the average in the European Union. Also is currently ranked, I think, at 26th or 27th position for water stress in the whole wide world. So households only consume 14% of the water here in Greece. The other is industrial use and water losses.
Oh, and if you could put an hierarchy on your challenges, the challenges that your sector faces today, on what would this hierarchy be?
We started this prioritizing our problems 5 or 10 years ago with some of our colleagues. I worked here for 5 years, 6 years. On the top of the list was water loss minimization. For that purpose, we have conducted three environmental impact essays, 3 constructive work essays, and we have developed a telemetry system to monitor our reservoirs, our pumping stations, and for that we have founded in the Ministry of Interior and got a total of 15 million grants for replacing our old networks. We also have an expected result for that for about 350,000 euros per year in energy consumption. We will minimize the energy consumptions, and also we will downsize the cost of repairing old pipes. So another thing was asset management. We haven't any priority for asset management. Now we have established a basic reactive and preventive maintenance systems, and through InnoWise we have come familiar with the idea of preventive and predictive maintenance. Another case is water quality. We have a small chemical and microbiological lab, which should be by the end of next year should be get full license from the government. So we made our best with what means we had, and from what we have experienced from other utilities. So this is the priority. The top of the priority is water minimization. You cannot talk about water scarcity if you have a water loss of 60% in our water distribution networks.
So very well, we have water minimization, asset management, water quality. Do you think that any of the startups of the scale-ups that are with us today will be able to respond to any of these challenges?
I think each and every one of these scale-ups and these innovative solution providers are capable of delivering a solution for a specific problem I have. So each and every one of them has a field of expertise. Nanoplasmas and embryo diagnostics are fully equipped for providing solution to our chemical lab. SIPE and Drupal are also covering how that Mr. Ramzi Buzurda mentioned, the last uncovered mile. That with the interaction between the end user, the customer, and the public authorities. They have special IoT technologies and software that can bring authorities and the end user together. And also there are more technological solutions that FIPS and Enzing are providing. And they are mostly using high-end technology for water loss minimization and detection, and also predictive maintenance, which are mostly all of our problems. So the selection of the solution provider was 100% match. If it was a film in Netflix, 100% for my case. It's and every one of them.
Excellent. Thank you so much, Mr. Seitaridis, for stating your challenges and being with us today. And now we would pass to our first keynote speaker for today. It's Professor Phoebe Koundouri. Professor Koundouri is a professor and director of research and laboratory at Athens University of Economics and Business. She's the director of Sustainable Development Unit and EIT Climate Kick-Up Greece in Athena Research Center, also a fellow World Academy of Art and Science, and many, many more. Professor Koundouri, the floor is yours.
Hello, I'm very happy to be here and be hosting this important innovation challenge. It is important to be linking the work of research with innovation and innovation acceleration. This is one area that our country is not doing well, and I am extremely grateful for all the institutions that are really collaborating in order to take this research, commercialization, and innovation acceleration further. I'm also happy for the opportunity for this speech, and wanted to very quickly present to you the cluster of sustainability transition that I direct and how this connects with innovation acceleration and research commercialization, and then give you some background on the work we do on water resource management, development of the design of urban water systems and so on. So this cluster is trying to transform research and innovation into sustainability action, and it merges the work of the Research Laboratory on Socioeconomic and Environmental Sustainability, RESEAS, at the Athens University of Economics and Business, which I direct and I've launched quite a few years ago, where we have many research projects, European, international, and some national projects on all aspects of the sustainability transition. This laboratory works very closely with the Sustainable Development Unit at Athena Research and Innovation Center, the biggest and most important information technology research center in the country. I was honored to be given the opportunity to direct the Sustainable Development Unit, where we do a lot of research and innovation work on the twin green and digital transition that is now the underpinning philosophy of the European Green Deal, but also for all relevant transition pathways that we are sketching out in order to sustainably recover from the COVID pandemic. At Athena Research and Innovation Center, we host the Greek hub of EIT Climate Kick. I'm directing this, and Lydia Papadaki is the manager of the hub. And here we also have many projects on accelerating innovation, research commercialization, and using systems innovation in order to mobilize the transition to a climate neutral economy and society. I think this work is of immense importance because it really allows the translation of ideas and innovations that are created in universities into deep demonstrations that can showcase how the transformation that is needed for the sustainability transition can be implemented. The cluster also works with the Sustainable Development Solutions Network, the bigger global network of universities and research centers under the United Nations, trying to transfer solutions from research and innovation to all other stakeholders that are relevant in this transition. The politicians, the policymakers, the financial institutions, the businesses, the technology developers, the NGOs, the civil society. I'm honored to direct SDSN Europe and co-chair SDSN Greece. And I will try to give you a very quick glimpse of what we do and how it is quite relevant to water as well. So we work in three different domains: research and innovation, innovation acceleration, deep demonstration, and education and training. I urge you to have a look at the SDG Academy of UNSDSN, where you can find free open access courses on all important issues of sustainability, including water, food, and energy. And I think this is one of the most valuable sources for education on sustainability in the world. We offer master courses and undergraduate courses and PhDs. We even have a virtual reality lab that educates entrepreneurs and investors in long-term is something that is particularly needed for the sustainability transition. And of course, we work in a very interdisciplinary, holistic manner, which tries to identify the different challenges, for example, a sustainable economic growth, climate crisis, biodiversity crisis, social inequality, and then given the current policy framework, we try to bring together the demand and the supply. Just give me 1 minute. Give me 1 minute. Okay, I am continuing, trying to bring together the supply side and the demand side. Supply side pointing to biophysical modeling, production, analysis, green digital technologies and solutions, and the demand side, preferences, behavioral economic stakeholder analysis, and merge all this in a systems approach in order to provide solutions, in order to co-design with all relevant stakeholders the solutions that will make up the pathways for the sustainability transition. The solutions include education, awareness, research, innovation, commercialization, but also financial solutions and policy instruments like taxation, regulation, certification, financial instruments. Water stress, a big issue. I've been working in water issues since 1994, which is a long time. And you can see on this map that Europe has huge issues. Countries around the Mediterranean have huge issues. And of course, water stress is a relevant stress for almost the whole of the world, really, because it's not just in a form of quantity, but it's also quality. So increased pollution increases water scarcity. And of course, water is relevant to so many different SDGs. These are the 17 SDGs of UN Agenda 2030 that basically is our global agreement, our global commitment on how we want to look, what we want to achieve by 2030. And you can see that clean water and sanitation are, of course, relevant to health, are, of course, relevant to innovation and infrastructure, sustainable cities, life below water, because whatever we have in inland water, it goes into our seas and oceans, and life on land, which is basically managing the way we use land and we use water. But of course, the nexus of water, food, and nexus, where we again have many projects, is also related to many other SDGs. So water is really crucial and critical in all this transition, sustainability transition. And very quickly, if we wanted a recent history of sustainability, which is, of course, do an understatement compared to the sustainability history, because sustainability entered the political agenda in 2070, but I don't have the time to go through all that history. But in 2015, we have the agreement, the UN Agenda 2030, and an explicit goal on clean water and sanitation. We have the Paris Agreement on climate change, agreeing to try to reduce to keep at a maximum increase of plus 2 degrees Celsius compared to pre-industrial level, the global temperature. And since then, we, UNSDSN, are publishing this Sustainable Development Report that every year that is showing how well different countries are performing with regards to the 17 SDGs and the 169 targets between them. And what, if you go into the report, 2015, 2016, 2017, 18, 19, 20, and 21, you will see that water is one of the most underperforming SDGs across the world. And of course, we know that 2018, we've increased the ambition with regards to global temperature, not to increase more than 1.5 degrees Celsius. And 2019, we have the European Green Deal. And the European Green Deal, although it has no explicit policy on water, there are many policies that are relevant to water. And I will come back to the specific policies, but you should know that the European Green Deal is consistent and compatible with the SDGs aiming at climate neutrality at 2050, reduction of pollution, clean tech leadership by European companies, and leaving no one behind. And in 2020, we have the coronavirus, we have the medium run response, which was the Next Generation EU, 750 additional billion in order to achieve a sustainable recovery from COVID-19. And the big reason for celebration is that after this huge non-linearity of the pandemic, the growth strategy of the EU remains the European Green Deal. The investments that will be funded by the Recovery and Resilience Plan need to be at minimum 37% climate related and 20% digitally related. And by the end of 2020, we have member state leaders agreeing to increase the ambition with regards to reductions in emissions to 55% by 2030 and achieve climate neutrality by 2050. And in 2021, we have a hectic announcement of regulations and law, the European Climate Law, the European Corporate Sustainability Directive within the EU taxonomy package of measures, the different areas that are included in the EU taxonomy as sustainable investments. And you can see that agriculture, bioenergy and forestry and hydropower that are quite relevant to water are included in the taxonomy. And of course, in a few months ago, we had the announcement of the climate package with 13 legislative proposals for achieving the 55% reduction in climate change. And here we have many different revisions, the ETS, the effort sharing population, land use change and forest, the revision of the Renewable Energy Directive, the revision of energy taxation, the revision of regulations with regards to cars, aviation, and shipping, and so on. So a lot is happening in Europe. The same is happening in the US, and the same is happening across many places across the world. So we are on this sustainability transition. At the Biden summit, leaders representing 86% of world economic output have agreed to decarbonization, and China committed to decarbonization by 2060. So based on this, what do we do? Well, what we
1 minute left.
Sorry?
1 minute left.
Okay, thank you very much. So what we try to do in this cluster of sustainability transition is to really identify how we can mobilize and join implementation of the European Green Deal and the SDGs within Europe in order to sketch pathways, technological pathways, financial pathways, and policy pathways that can allow us to move to our vision, which is sustainable Europe by 2030. These are the European Green Deal policies: biodiversity, farm to fork, which is sustainable food systems, sustainable agriculture, clean energy, sustainable industry, building and renovating, sustainable mobility, eliminating pollution, climate action. All of these have a lot of water content. I am in the policy committee of Water Europe, and you can see, and Christy Laspidi, who is the vice president, will tell you how much water content there is in the European Green Deal. Now, with regards to actual projects, and you can read about all that I have in these slides, with regards to actual projects that work on water, I will refer very quickly. And since you've been introduced to this particular water scarcity project, I will, I wanted to refer very quickly to our current projects in water. And I just need to change this slide, and give me 1 minute to do that. And sorry about this. Very quickly to go through our water projects. One of the biggest one is the project on an ERC project, a 10 million project on water, designing next generation water infrastructure. And what we do there in a very interdisciplinary framework, we bring together economics and decision theory. We bring together artificial intelligence and machine learning. And we bring together water engineering and optimal control in order to design the next generation of water futures for urban water utilities. This is one of our bigger projects, a 6-year ERC project. Let me also introduce maybe very quickly the other water-related projects, and I'll leave it there then. So, sorry about this. So our water projects have to do with managing water in Europe, in coastal areas, in understanding the coastal interface between inland and seawater, in understanding the use of water in agriculture, smart agriculture, water, food, energy nexus, and of course the big ERC projects on supporting urban designing next generation of urban water systems. In addition to these projects, we also, of course, work a lot with innovation and research commercialization through the KIC and many other activities. And I urge you to look at the site of EIT Climate KIC in order to have a look how our efforts in terms of accelerating innovation, especially through an accelerator on maritime shipping, can support startups, incubate them, finance them, and connected to many venture capitals inland and abroad that we worked with in order to help them find their climates. In addition to this, we also have a big section with many Horizon projects on blue growth, and another big section on climate change, biodiversity loss, how we meet these challenges and how we recover from COVID by meeting these challenges together with the economic crisis. But I don't have time to show you that. I hope that this will be enough. Thank you very much for your patience.
Thank you a lot, Professor Koundouri, for your wonderful speech. And now we're delighted to have with us also Professor Chrysi Laspidou. Professor Laspidou is a professor at the University of Thessaly and also Vice President of Research and Technology Water Europe. Professor Laspidou, the floor is yours.
Okay, can you see my screen? I think yes. Right? Okay. So thank you so much for inviting me here. What a nice idea to match the problem owner with the solutions, the innovators. I think this is how we achieve change, and this is how we show to the world that real problems exist and the solutions are there, and we just need to bring them together to match them in order to advance this. Okay, so I just want to go through just to show you, so water scarcity and the utility sector. We've been working on the utility sector for some years now through some projects, FP7 and Horizon 2020. There was one FP7 called ISS Evatos that finished, and Water for Cities was the second one that is finishing up. And we also got funding through the Stavros Niarchos Foundation to explore the conditions specifically of Skiathos. Skiathos is an island in Greece that has some issues. So let me just show you a little bit what this water scarcity could mean. Of course, we've had Mr. Seitaridis before, who said very nicely what the problems are, and they are, these same problems are found everywhere in Greece, but sometimes things go really wrong when it comes to water scarcity, and unfortunately, things will probably become, progressively worse with climate change worsening and climate change impact becoming more prominent around our systems. So we checked the conditions, and we used as a case study Skiathos, which is a small town in an island in the Aegean. There, the pressures are tourism. So, I mean, the biggest pressure is tourism. So you don't have so much, you don't have industry, you don't have so much agriculture anymore. It's one of the really touristic islands that hosts many people seasonally. This happens during the summer months. So imagine these small islands that already had issues with water scarcity. Water is not so plentiful there. They take it from groundwater. This is another thing. It's almost 100% from groundwater. And because the groundwater is naturally very close to the coast because it's an island, then you have the salinization. So you have salty water coming in the groundwater, the aquifer, and making the water saline. So eventually what you're pumping is brackish water. And of course this is a problem by itself, that you probably need to find solutions, and the water is not good, not so much for agriculture or for other uses so much. Here though, we have a different set of problems. Of course, we have aging infrastructure. What we heard about in Pylea and Hortiatis, here I think we had one of the highest. We estimated about even 75% of leakage. So imagine in a place where water is so scarce, to pump from groundwater and lose about 3/4 of it. It's really insane. So, and of course, this is not so unique to Skiathos. This is also happening in other parts of Europe. The networks are, aging, and it's not easy to replace all of them. I think we are at this phase where a lot of them are reaching their, the maximum age that they could have. So what can we do? Of course, we can replace, but then again, we find ways to be smarter about it, to use sensors to best, to best operate these systems in an optimum condition. One of the things that we do, of course, whoever is in this area knows, is we do pressure management. The idea is to, on the one hand, provide enough pressure for people to have pressure in their network. So when you open your faucet, you want water to pour, not to drip. So you want to have enough pressure on the one hand. On the other hand, you want to have the minimum pressure in the network so you don't have leakage. If you imagine the networks as imagine a hose that has holes in it. If you pump water really hard through it, you will have a lot of the leakage. If you don't have so much pressure, then the leakage is less. So this is one way, is to minimize pressure in the network in order to maximize and also to have enough in the faucet. Now, depending on the bold relief, depending on the geography, you might have a hilly area where you need to pump the water there. And we have seen in cases like Scathos, for example, in order for the water to reach that high level, they were pushing it at a really high pressure, which of course was the worst solution for the water loss, for the leakages. So we established a smart system there that we had developed, a system with sensors. So sensors are placed at various places in the network, at the critical points where it's either the farthest point or the highest, where it is actually critical for the network. And we were checking pressure and flow in those points. And then we had forecast models with the neural network and other artificial intelligence algorithms that would predict, for example, what the consumption would be the next day, the next week, the next month. But we were doing this, we developed those curves for an hourly, with either 4 hours or we could go even down to 1 hour predictions. Of course, the forecast that you have is as good as the data that you feed the system. And that's where data becomes very important. So a lot of these innovations might have to do with data, with sensors, and it is really critical in order to be able to use our models to have enough data that will give us good predictions. A lot of these artificial intelligence models are relying on a plethora of data. So you want a lot of data. Here we managed to work and get very good predictions with the minimum data that we had and with the 3-month bills that people get in their waters. You don't have smart meters. If you have smart meters, you know what people are consuming, then things are easier. But in the absence of those, and if you imagine in an old network like the one we had in Scathos, of course, we did not have smart meters there. Anyway, so we managed to make some very good progress there. And we even got, I think, a special recognition because we had such a huge impact. You know, when things are so bad, even the littlest things you do really creates an impact, which was very nice. Now, this is pretty much the average picture, I would say. There is not, not all cities are so bad as it is, but a lot of them have high leakage. I mean, 20 and 25% is, I think, is considered relatively average to low. So if you speak about 40%, that's when it gets higher. So leakage is there, and it is important. It's something that we definitely need to tackle, especially when we don't have enough water, so we can't afford to lose it. And if you see in the long term, this leakage becomes also very expensive. You have damages, you have bursts, and if you don't really operate the network in a sustainable way, really the damage that you make is massive, and this could cost a lot of money. When people usually say there is not enough money to fix this problem, money is spent just spent after the fact. Now, one complication here that I wanted to share with you with Scathos is that the natural rock system of the aquifers is cinnabar. Cinnabar is a type of rock that is, as I said, is natural. It's not anthropogenic pollution. But cinnabar is rich in mercury. So cinnabar, by its nature, it contains a lot of mercury. Mercury, as you know, is a very toxic heavy metal, very toxic. You don't want it anywhere near you, not in your water. Now, under regular conditions, these rocks are happy to be in contact with water, with fresh water, and everything is nice. You have no leaching of the mercury. Mercury stays in the rocks. But when you have so much saline water coming in, so much salty water coming in, eventually your fresh water becomes almost salty, what we call brackish. That is not what it is intended, what nature intended for these rocking formations. So what you do is you mobilize the mercury, and mercury leaches out in the water. So this is what we have. We have, yeah, let me just go through. I want to go, and this is where we report. This is a recent, I mean, it's going to come up in 2022 in Chemosphere. This is the work funded by Stavros Niarchos, which was targeted towards characterizing this mercury. So what these people did, this is the chart that shows water consumption. The blue lines, the blue bars are water consumption, and see how high it becomes, how it peaks. These peaks are in the summer. So this is the summer, and then you drop for the winter, because winter, everybody's gone. Few people are the locals that stay there. And then in the summer again, you have all these really huge amounts of water being demanded compared to the baseline, which is the winter time. Now, as you can see, progressively throughout the years, things become more and more. So more people live even permanently in Skiathos. So you have more of the water demand, but also peaking. Now, these are the blue lines, and this is fine. I mean, we're all happy to see the tourists come, and there is income and blah, blah. Well, you know, we're all very excited to see the tourists come, actually, in the summer. But look at the blue dots, the black dots are the mercury concentrations. And the flat line is what the World Health Organization considers safe. So look how far we are above safe. And it goes up to six. I mean, when the limit is 1 microgram per liter, we go up to 6 for this. So this is, and you will see a drop here, which is artificial, basically, because the people in Skiathos, you know, we consulted and they started mixing some fresh water from springs in the water. So it's not that water coming from the ground is not heavy, you know, it is not rich in mercury. It's that they mix it now. And still, of course, they cannot get it down to what it should be. Still, it's way, way up there. And of course, the water is such a sensitive political issue. So this is a really an important, and given that mercury is so toxic, and given that, you know, I've heard people bathe their babies in bottled water because you don't even want to have this on you. You know, if you're a small person, like, you know, like I said, like a baby or a pregnant woman or whatever is, you know, a sensitive and vulnerable part of the community. Now, so this is one thing to show you, okay, you have the leakage, you have the non-revenue water, because all the water that is leaked is non-revenue for the utility. Let's not forget that the utility sells water. And if 75 of it is lost, it's like losing 75% of its income and adding to the expenses. So it makes the water utility not operational, and not operational, but it makes them not being able to, you know, to make enough money to invest in the network, because there are so many losses. But here you see how such a problem of, you know, water scarcity can create other, you know, cascading effects or other side effects that are really massively important for public health. So, and in this graph that I show here, the green, and people started seeing this mercury, and it was like, we don't know what it is. What is happening? Why is it here? Then for many years, you know, when we came in as University of Thessaly, there was not knowledge where it's coming from, what form this mercury had, because mercury could be variably toxic depending on the form it is. If it is depending on the valence, you know, is it +2, +3, is it 0, is it organic mercury? You know, depending on the form, it's much more toxic or persistent or mobile or dissolving or settling. There's all these different issues to confront. So when
things left, Professor Laspina.
Sure. So when things are not working and operating the way they should be, then things are starting going wrong, and then the whole system becomes out of balance. So here you see the connection with chloride. Chloride it is strictly connected with salty water. When salty water comes in, you see the mercury peaking. So if you look at the peaks, the one follows the other. So, and many people speak about, okay, mercury, maybe it's very specific, maybe it's only in that part of the world. It's not. It's a lot in the Mediterranean. You have arsenic, you have mercury, you have, we have this project, EU-India project called Lotus that we run, a Horizon project. There they have fluoride, then arsenic. I mean, the problems of heavy metal in the groundwater is not unique to Skiathos. It's extensive to other places as well. And it is related to what we do, and it is related to water scarcity. Water is scarce and people overpump, and there is not enough fresh water to supply the community. So we are thinking of what it is we should be doing with these problems. We're looking at different pHs. We're looking at how it can change and how we can measure it. Here, there is a challenge in measuring mercury for me, because it's not something that you easily measure with a sensor. It's something that you have to take to the lab, and nobody wants to deal much with mercury when they test it because it's so toxic. So it's not so easy. So here's an idea for the innovators to start looking into solutions on how to measure mercury. For me, one promising solution is to consider chloride as a proxy variable and try to link chloride with algorithms, link chloride with mercury, and be able to predict mercury while you're measuring chloride, which is very easy to measure. Conductivity is, trivial to measure. Okay, and just to finish, people might say, okay, who cares? If we just pump the water and we don't drink it, it's okay then. We don't have the damage. It doesn't cause cancer. It doesn't cause all these things that mercury causes. But think about it. You take mercury out of the ground and you pump it up, above ground, and you wash, water your plants, whatever. And then it goes, it comes in the ecosystem and then it goes in the sea. We actually put, as part of the Niarchos experiment, we immersed mussels, because mussels are like filters for water, because it wasn't easy to take daily measures. We immersed a bucket of, a cage of mussels, and we checked them, we pulled them up and we checked them a few months afterwards to see whether there is something coming from the sea. And we did actually saw stress. We saw stress. It's not directly linked. It's not easy to link, but we identified stress comparing to the control, because we also had a control in a different part of the sea. Okay, so I don't want to trouble you. I just wanted you to see, how things could go wrong, from water scarcity, and when the conditions are like this. It is urgent. It is really urgent that we find solutions for our scarce islands. It is urgent to find solutions during the summer months, and the desalination, it could happen, but it's not the panacea, because then you have the salty water, the brine that goes in you put it back in the sea and it goes down in the ocean floor and really creates a desert down there. So it's not one of my favorite solutions. I think the aquifer recharge, getting the water, treating it and recharging it in, so we keep our aquifers at a good level. This circularity in water use would be a really top solution. And there's a lot to be done in trusting the water that has been used and repumping it. There is a lot of this stakeholder and a lot of trust issues. Maybe people speak about blockchain technologies that could be used to alleviate these doubts that the public might have in, reusing. So I will stop there. And of course, we're here to, to talk more about it. So thank you. Thank you for giving me this opportunity.
Thank you very much, Professor Laspidou. Now it's time to pass to the pitching sessions, and we start with Drupal. Together with us, we have Ramsey Buzerda, founder and CEO of Drupal, who will present us his idea in 4 minutes, which will be followed by a 4-minute Q&A by our jury.
Yes.
Hi, InnoWise Challenge. My name is Ramses, founder and CEO at Drupal. Our vision is to make water matter to people. Today, we are still blind to what happens after the main water meter, leading to water and energy waste, unplanned maintenance, and unmet need. How can we challenge a 40% shortfall in global water supply in less than a decade, combined with an increasing quality concern at the tap if we are such blind? More than 36 billion water assets have in common water usage and quality parameters that can be leveraged to assess their health, maintenance need, and usage insights. This is why Drupal has built a B2B IoT monitoring solution to make those assets smart, with the patent-pending intelligent iLink able to speak to our AI-enabled platform. Drupal offers to service providers zero unplanned maintenance, more consumable sales, and automated procurement, while providing end customers with water and energy savings. We have designed a full recurring business model for growth and alleviate the hardware barrier. After 3 years, we provide tangible value with our customers, such as facility managers, filtration system suppliers, and water dispensing providers. Our objective is to land 30 key customers by the end of this year in those verticals. To outperform our achievements with strong sales figures and ramp-up pipeline, as well as a worldwide recognition for our innovative technology. We stand out from the crowd as the fully retrofit and multi-sensing point-of-use monitoring solution. I'm thrilled to lead such a blend of talents and experienced team of 12 Drupalets bound to a sustainable vision. To fuel our growth, we are raising a 6 million Series A, half equity, half debt, to ramp up sales, scale supply chain, and consolidate our company. For DIA, Drupal is the go-to platform, providing a plug-and-play integration layer with the iLink, combined with an API, data, and event-driven integration, easing the digital transformation. Challenge water scarcity statu quo. Join us to make water matter to people. Thank you.
Okay, so questions, please, quickly. We don't have so much time. I want to ask a quick one. Could you please tell us in a couple of sentences the biggest problem that you solve with your solution? So what is it that you do? Where do you contribute specifically? Which is the biggest innovation that you have?
Yes. Today, we all receive a utility bill for our water consumption. It doesn't mean that we value water. And Drupal's innovation is to connect people with their water usage and water assets. And today, the last mile, what is happening beyond the main meter, is uncovered because we don't know what is happening. It's like you are earning money with this water coming in facilities, but you don't know how you are expending it. We bring this expense transparency and how you can better expense that water.
Right. Please, the other member of the jury, please. Jump in. Yes, Gianluigi, please. Yes.
Thank you for your presentation. I just have a couple of questions. The first one is about the final user, because for me it's not clear if your solution is for example, for a municipal domestic user or just for wastewater treatment agency. And the second one is about maintenance of the sensor. Is sometimes something that needs a periodic maintenance, or is something that can be calibrated, for example, for remote? Just this information. Thank you.
Yes. So for the first one, we are a B2B company, so we are selling our solution for businesses that are selling water assets. It could be water treatment systems, sanitary ware, or appliances. Now, the data we leverage and the services we provide could be used for maintenance purpose from the service provider, but also for the end user that is using that water assets. And this one could be an end customer who is an employee or just a homeowner. Now, for
Thank you.
The question for maintenance, our hardware can last between 5 and 10 years with one single battery. It's battery operated. You don't need AC plug. And then you have to change it. And in our platform, you have a predictive end of life of the battery and when you have to maintain our sensors, but also when you have to maintain the assets. What it happens, the service provider, as it has to go to maintain the water assets, make the maintenance of the sensors in the same time.
Thank you.
May I ask? So if I understood correctly, in order to offer this all-around solution, you also rely on collaboration with others. I saw, for example, Brita, or I saw, how do you call, anyway. So what does this mean for your risk management in order to rely on others for providing the solution, if I understood your solution correctly?
What do you mean by risk management?
Eleni, we can't hear you.
Yeah.
Sorry. How do you want to place your product in the market? And what does this mean in case you rely on collaboration with others, as I saw in your slides?
Yeah. Actually, we sell to people that are directly interested to use our solution, which is the company that maintain water assets or do cleaning services or actually have already installed those assets to their businesses. And the idea for them is to reduce the maintenance cost while increasing their sales with more consumables sold to their end customers. So the incentive is directly related to the purchase of our solution. And we can, of course, along the value chain, provide new services to the end customer of our direct customer, which means that we can onboard more customers at the end. Is it clear? Yeah. Thank you.
Thank you a lot, Ramzi Buzarda. And now we pass to our next scale-up. It's Saib, and we have Alexander McCormack, the co-founder and CEO of Saib, to present us his idea.
Hi, I'm Alex McCormack, CEO and co-founder of Shape, and we are helping society become more resilient facing water shortages by reducing the water demand in buildings by 20%. Now, the overarching problem is that 1 in 3 buildings present leakages every given year, whether it be non-residential or multi-residential buildings, and this accounts for over 20% of the water usage in buildings. To give you a concrete example, in the public buildings of the city of Brussels, over 40% of the water usage was attributed to leakages, such as leaky toilets, water softeners, heating systems, faulty valves, you name it. Shape provides the most effective and scalable way to address this issue at large. We're improving water efficiency standards across all types of buildings and sizes. Simply based on the utility meter, we can inform customers how much water is being wasted in real time in the properties and provide guidance to improve the situation. We've detected over 12,000 leakages and just crossed the bar of saving 1 billion litres of water. Now, the first step is to gather the data in real time. If there are smart meters, that is great, but it's usually not the case. So we've manufactured and built and engineered and patented a retrofit module to transform existing utility meters into high-performance smart meters. The data resolution is over 30 seconds and has a battery lifetime of over 10 years. We just made a breakthrough and is going up to 16 years now. Once we gather that data, we run through it through our intelligence. that we've coined autonomous dynamic flow analytics. Basically, what it means is that without any human intervention, any manual calibration or arbitrary thresholds, no matter the size of the building, we're able to assess very reliably what the leakage is. We present that in a very user-friendly manner to the end user, where we tell them how much water is being wasted, what's the most likely cause of that issue, prioritize their actions cost effectively, provide them reports on the savings and the leakages that are being repaired. We've been serving property professionals for the past 3 years, and time again, we've proven that we can reduce water consumption by 22% on average simply by eradicating existing and future leakages in buildings. Water utilities are turning towards us to be able to digitalize their operations more easily and effectively, reduce water demand overall, and provide the public with a better customer experience. In fact, the largest Belgian water utility is launching EasyConso, where the underlying technology is Shape. Furthermore, we've just been starting to apply our technology to water towers and reservoirs and making municipalities more independent regarding their water resources. Shape is ready for Europe, Asia, the Americas, and Australia. So if you wish to learn more, check out our webinars, our blog, book a demo online, or we can start kicking off a pilot as soon as tomorrow. So please join us and we can shape the future of water together to make our society more resilient facing water scarcity. Thank you.
All right, questions. Ortwin, maybe, do you have a question? Because we didn't get the chance to ask.
Yes, I have a question. What should be the cost for the customers on a monthly basis to install such a system?
So when we target directly property professionals, when we sell it directly, it costs anywhere between 200 to 500 euros per year per building. And so it's an IoT-based SaaS, yeah.
And this is just one system on 1 meter, or is it
yes,
global?
yes, yeah,
meters?
Yeah. Now, when we work with water utilities, for example, it's just a service model. We become a technical provider with one point of contact, and they can either offer that for free in turn to the customers. That's been the case in the past before, or in other cases, they even resell it.
Okay. And is it destined for individual homes as well?
There has been a use case indeed where we've serviced, there's 3,000 smart meters being installed, and the citizens have access to a home application.
Okay, thank you.
Okay, very good. I think Gianluigi had the question, please.
Hello. Hello, and I have just one question about, according to your previous experience in some case study, like I see in some city of Belgium and other agency, which kind of solution can you propose according to the situation? For example, if you detect some shortage in water or some overuse, if you can give me an idea what kind of solution you can suggest in that cases when you contact and the feedback of the user in that cases.
Yeah, absolutely. So as a matter of fact, I can talk about two cases. One is a case where we've actually, when there's leakages that are being detected, let's say it's a property professional, we can put them directly in touch with a third-party leak detection provider. So they would actually dispatch maintenance there as backup. So there we act almost like a marketplace, where we take also a commission fee there. There's also been another use case, for example, for homes, where it's actually their insurance that takes that as a measure of support, because it's also in the interest of the insurance company to provide assistance before water damage occurs. And then in the use case for a water utility, they can actually also provide this service to the end party, and also is another way of generating revenue.
Thank you.
All right, Eleni, yes, please. I think it's a great solution for individuals. My question is, why should they choose your solution, and how can they convince their customers in order to install these utility meters, and how will this cost be covered?
Yeah. So very good question. So the most important aspect is actually you start with your highest paid customers. Those are going to be high water consumers. So for example, yeah, property professionals, multi-residential buildings, non-residential buildings, these sorts, even public buildings. They'll be the first to pay for it. You can actually get them to pay it for quite a high price. With a high margin, and this is a way of financing a gradual rollout. Once you start, we'll be able to help Greece start to digitalize their operations as they gradually go through, and then after that, you can scale this at a much larger scale to make it more available to citizens. But this you would need external sources of financing, but at least you'll have a strong use case to be able to prove that it works.
Okay, and so so what you do is you convert the conventional meters to digital meters, right? By applying this. And can you advise like where water is lost in the house? Like, is it in the, I don't know, in the leakage or in the shower, or do you distinguish among uses or not?
Yeah, so we're able to distinguish whether, for example, it's the water softener or whether it's a leaky toilet, for example. We're not exactly able to pinpoint where the leakage is, but it's enough already to assess whether any intervention would be cost effective for the end user. And it generally is, quite frankly.
Okay, for me, it would be nice if you could also, monitor the different uses and say, compared to the average, you're overusing, for example, your shower or something like that. So usually,
yes,
people how to save water, how to change their habits. So.
Indeed, we're currently working with a research institute where we're doing non-invasive load monitoring. So it's disaggregation on water consumption. And we made a breakthrough on households where we're actually indeed able to assess where most of the water usage is going.
All right. Okay. Yeah. I need to stop. Thank you. Thank you so much. Go to the next one. Thank you.
Thank you very much, everyone, both the jury for the great questions and Alexander. And now we need to pass to the next scale-up. It's MBO Diagnostics, and Konstantinos Loizou, the founder and CEO of MBO Diagnostics, will present a speech that will be followed by 4-minute Q&A.
In 2007, I witnessed an event that sent 2,000 people to the hospital through bad water quality. A food poisoning that happened to an Easter festival that it took days to identify the source of the problem. In that moment, I realized that we need faster, portable and accurate solutions in order to be able to address this issue. I am Konstantinos Loizou, Director and Founder of MBO Diagnostics, and I'm going to show you how we managed to address this issue by bringing solutions to the market and how we can help our problem holder in order to bring them a solution to the market and solve their water loss issues and water quantity management that they currently face. The Achorchiates are battling with standardization and digitalization needs that we can help them build through portable diagnostic technology for years to come. Our solutions are certified, and through 2021 we managed to finally bring our innovations from the lab to the market through our constant certification and our constant R&D development. Through tracking water quality and safety monitoring, we know that every solution that we can use to bring to the market needs to be low maintenance, scalable and easy to use. We should never forget that the people that are already facing this challenge daily are the ones that are going to use this technology for years to come. We need it to be long-term and long-term operating. That's exactly how we designed our out-of-the-box solutions. BELT is the fastest bacteria monitoring and can be used only with our custom hardware and biotechnology and mobile application. AirBelt can give you specific virus detection and identification through a portable device app and through specific email alerts. West Smart System has saved thousands of resources to farmers and users that know how to use their water now better than before. Our solutions are designed like this: faster, cost-effective, and based on data analytics. We aim to identify a problem, make sure that we can build with a solution that is not available in the market, and identify where we can enter with our competitive advantages. That's why we are using data, that's why we are using biotechnology, and that's why we are using our custom hardware innovation. We know that we act in a very competitive market. That's why we use our patented diagnostic technologies and our continuous R&D to be adaptive and identify the opportunities that come from regulation changes, and specific through Green Deal. We know that we act in a highly competitive market, but that's why we partner for distribution and manufacturing that can help bring our innovation in numbers that can be available in specific market shares. We have faster, digital, certified, and now we have the ability to produce and distribute product. Our water-based solution addresses one of our customer segmentations, address the environmental applications that we face through specific water management and water testing solutions. We know that we address a total market over 15 million and that we can tap this market in the next 5 years. We can do this because we have been identified from Microsoft and from EBRD as winners, and they have given opportunities in infrastructure. We have been identified through our team and through our achievements of innovation. We know we can help our solution provider and our problem holder be the solution providers for our problem holders. We know we can do it through digitalization and low-cost, long-term operation. We're looking forward to work with the Iachoriatis and being a solution provider.
Yeah.
Yes. There was a synchronization issue, at least.
Right. Okay. We have a question from Ortwin. Please go ahead.
Yes. I was wondering, you are measuring bacteria online?
Yes.
I understood. Yes.
We have the ability with our technology to detect on-the-spot bacteria, and we can do it with the minimal time for incubation. So every information is shared online, and you can have your results directly. So it depends on the bacteria that you like to monitor. We don't have a full range of bacteria, but we have successfully even commercialized Listeria detection in 3 minutes.
Okay. And what exactly is the method that you use to do that detection of bacteria? How do you manage it?
Yes, thank you for the question. It's a patented method we have that is involved with living cells, and we measure the response of the cells when they actually detect one specific substance. So that's why we are so fast, and that's why we can do it with smaller incubation times.
Okay. And is it a very expensive method to
It's a very cheap method, basically. The cost is basically the consumable. The average cost for every test is around 15 euros.
Okay. And is it possible to get it online so you have a continuously measuring?
Yes, the manual action. Yes, thanks. The manual action is to get the sample and put it on the device. So that's something that's currently done manually. But transporting live has already been designed and can be done by using a simple machine that can basically prepare the sample and then put it on the device.
Okay. Thank you.
All right. Okay. I saw some discussion, I guess, about COVID or SARS, the SARS virus. Is there ability to...
Yes, from when the pandemic actually came to Cyprus, and we started using our technology, as Mr. Orwin said, we have the ability to be very fast and very quick and very cheap in every detection. So we wanted to use the same innovation to do the medical. It took us 6 months to prepare the first tests. You currently know them as rapid tests, but we have been doing it from the April of 2020. We managed to reach accuracy above 97%. It's completely certified, and actually it's available in European Union databases and in mass production in the next month. Mm-hmm. And it's completely licensed product. You can search it by the name of CoughBelt. I can write it here in the chat.
And it detects SARS, the virus in drinking water or in...
Not in drinking water. It can detect it on either patient sample or environmental samples. We were basically now in the middle of a huge pilot study in the General Hospital in Nicosia, where we sampled the whole hospital to actually identify the spread of the virus from the chambers to the normal corridors, which is a big issue, especially in close environments.
So this is beyond water now, but it is also the side business of what you do. Okay, I understand. Very good. Any other question? Eleni, Gianluigi?
Yes, please. You mentioned that your online platform uses proprietary algorithms in order to continuously improve and machine learning techniques and development. Mm-hmm. So the question is, if they are purchases your solution, how can they prevent a possible vendor lock-in? And after some years, if they want to for any reason to change the system.
Can you repeat the question? I didn't understand exactly.
You said that your platform uses proprietary algorithms to run. Mm-hmm. So how can they prevent a possible vendor lock-in? If they decide to change the provider.
So, for example, like they have in Siemens and they are locked with Siemens for years to come.
Yes, and in this case, they will be locked with MBO Digital platform.
Not exactly, because what they will have is an additional framework that they will be able to base their results and their accuracy on what we offer them. It will be an additional information, not their SCADA. That was one of my questions, one of our discussions also with Thomas. We wanted to understand how locked in they are in SCADA and how we can be an additional resource on that. On my thesis, I had the same problem. I worked with a water department in Chania in Greece, and everything was locked in SCADA. So whatever you can do, you should pass through SCADA, which was a big issue because of license and the cost of license and all these things. So I was very aware of this issue, and we don't think of something that you are locked, but we are able to provide you some insights. If we're doing the work correct with our insights, that makes us useful and likely to be there.
All right, very good, very good. We need to wrap up. So, but very nice.
Apologies for the bad noise.
Yeah, but
the bad synchronization.
Good solution to that noise. Okay. Thank you, guys. We'll move on to the next one. Good luck.
Thank you very much, Efren. Now we proceed with Citizen Monitoring and Javier Sanz, who is the co-founder and CEO of Citizen Monitoring. Javier, will you present us your pitch?
Hi, everybody. I'm Javier, the CEO of Citizen, the company that wants to improve safety and efficiency in water management, because we know that water is important for life and climate change is hitting the world. But currently, the water companies are losing more than 20% of water, and their management processes are inefficient. The main issue is that they don't have real information about what's happening in their facilities. Monitoring systems are expensive and not truthful. So to solve these challenges, we provide a real-time monitoring and predictive analysis of water and facility conditions, where water companies can save, operate and maintenance costs and ensure a water secure. This makes it possible analyzing the changes of light emitted by the interrogator as it travels along the sensor cable. And we relate them to the phenomena that cause these lights, changes, such as temperature, strain, etc. Finally, all the data and analytics are shown in the user-friendly dashboard. It is an innovative solution that allows us to give our customer an all-in-one simple custom solution, small in size, with a single device and reduced maintenance cost, where the customer can choose the solution based on their needs. Furthermore, the excellent resistant properties to water, or that the on-fiber can be the element sensor, make them perfect for real-time large distance monitoring. In the market currently, we can find that the most advanced monitoring systems use punctual sensor or use different devices for each measure parameters. They are not so easy to use and very expensive to maintain. So we want to do a leapfrog solution that is more efficient with less resources, bundling all monitoring sensors in a single cable. In these years, we have worked in validating our first solutions in real environment with the help of Global Omnium, a water company reference in Spain, and the Polytechnic Valencia University. In addition, we are developing new solutions for next year, always with collaboration of these partners. Focusing on the case of our problem holder, we propose a smart monitoring system that can control along 1.3 kilometers of polyethylene pipeline, leaks and intrusion security. As well, water temperature and pressure will be analyzed in 3 points of the pipeline. And finally, all of this data will be displayed in dashboard. The cost of everything, it will be around 30,000 euros. Finally, I would like to introduce the team. Demetrio is the fiber optic engineer, David, an electronic and data engineer, and me, Javier, civil engineer. So this is Fipsen, and we are happy to connect to you. Thanks.
Okay, very nice. Thank you for this presentation. So if I understand well, you don't have any modems, right? It's all happening through, everything goes through the fiber optics, is that right?
Yes.
It's not the Internet of Things, it's not IoT, it's not wireless sensors, it's all wired through this, is that right?
Yes, you're right. We use a theory based in the phase of the sensitive optical time domain reflectometry. So we changed the electronic pulses
yes.
To transform in optical light. So we transform the analog to digital.
I see. And I mean, the benefit is that it's more reliable compared to the other.
Yes, it's more high sensitive. We work in nanometers. So we can detect, for example, in temperature, we can detect 0.000 degrees. So it's very effective.
Okay. And you can connect any existing sensors or, whatever the utility has, or you have your own specific instruments that needs, equipment that needs to be placed in the network?
We use the own research sensors, because this is a patented technique where we can install all our sensing inside of the cable according to the customer needs. So only need 1 point, and all the sensor is embedded in the multiplexed or distributed sensing.
Okay. And you don't have a decision support system afterwards. We just provide what it is, where the, whatever, pressure, flow, temperature, whatever data, you just depict it along.
Currently, we are develop leak detection, temperature, pressure,
okay,
and security, intrusion, for example, and vibrations, acoustic sensing.
Okay. Any other question from the?
But we are working in new solutions. Mm-hmm. We are currently we are research about water quality analysis, pH, chlorine.
Okay, very good, very nice. Questions, please. Yes, Janvi, please.
My question was about water quality, but somehow you have yet discussed about it. But I still don't understand if you are working on if you can yet, or you're working on also some parameter about chemical analysis, like pollutant or TDS, mm-hmm. or also, for example, microbiological. I don't know if it's possible to do with such kind of technology.
I think it is possible because we are working in several method solutions, but nowadays we are working in that. So very difficult to say yes, I could, but we are working pH sensor, for example, and we have tierly level in H. For example, we work in laboratory and we have a very good performance.
Okay, very good. Let's give a chance to Ortwell to ask, please. Yes.
I was wondering, the Water Group is a drinking water company which has about 30,000 kilometers of mains. Is it realistic to?
Can you repeat, please? Because
okay, the Water Group is a drinking water company in Belgium, and we have around 30,000 kilometers of mains in the ground, so drinking water pipes. Is it realistic to install it on the whole network, or is it just for some detailed sections?
Did you hear it, Xavier? Did you hear?
I can finally.
So he asks about the length. He says in his water utility he has 30,000 kilometers. So will you be able to cover such large distance or just small parts of the network?
The benefit of this system is in the large distance monitoring, because with one interrogator we can measure 70 kilometers or 100 kilometers. So it's very cheap when you monitoring large distances.
Okay.
And you can connect for example, in one interrogator you can connect 100 or 200 sensors for pH sensor, pressure sensor. So it's very beneficial.
So it is suitable for large distances, yes. Okay, yes. Eleni also had a question, please.
Yes, actually two in one. You said it's 30,000 euros, the cost for your solution. So does this mean that the fiber network needs to be in place and then you come afterwards and implement something additional, your solution in additional way? Or you need to install the fiber networks from the beginning? This is the one question. And the second one, how mature do you consider your solution? If I understand correctly, your work is based on recent R&D projects. So how confident are you that your solution is fit for the market?
Quickly, please, because we're out of time.
Okay.
Xavier.
And the first is, I understand about the the sensor, not modify the sensor, implementing new sensors, you say?
Do you need to install the fiber network, or
okay.
Can it be?
Yes, at the first you need to install the sensor cable, but in the future, if you need to modify adding or removing new sensors, you don't need new installations. We are developing all our sensors with the idea that it must to be installed inside the cable. Mm-hmm. So new solution also be incorporated in the cable. You don't need a new installation.
Okay, we need to close this. Thank you so much.
Thank you. Mm-hmm. As well.
Good luck. Okay.
Thank you a lot, everyone, for the questions and the nice discussion. Now we pass to the fifth scale-up for today. It's ending, make solutions, and we will listen to Walter Sampio, the Chief Security Officer at Engine, presenting their idea.
Hello, my name is Walter and I come from Engine. Engine is a Portuguese company founded in 2011 that created and developed solutions for predictive maintenance, in this case applied to monitor the operating conditions of electric machines. So we are able to give you an online real-time monitoring using a completely non-invasive technique that in the end is able to detect and to pinpoint the exact location of degradations and very incipient faults inside your electric machines. So this is applicable to rotating machines, pumps and motors, pumps even when submerged, transformers, either being distribution or power transformers, the power electronics, the wind turbines and the solar PV farms. By the numbers, we are monitoring more than 10 gigawatts and having 25 employees. So we are able to optimize the asset lifecycle management, maximize the machine lifespan, prevent catastrophic failures because we are able to detect 80% of the future potential faults. This will obviously help you to reduce the regular maintenance costs and also decrease the unplanned downtime of the production process. Well, the problem is being continuously introduced by the traditional approaches. We are talking about non-actionable information, meaning this information coming from these traditional approaches is inefficient, is insufficient, it is not permitting you or allowing you to reduce large number of failures and planned stoppage, high downtime costs or maintenance costs. In the middle of this process, you are incredibly being exposed to risk because they need to place a sensor inside your electric machines. So you're having a human and a property risk. So we have developed a solution that is overcoming this problem, a solution that relies on the mathematical algorithm constructed on top of electrical deterministic methods. Well, this mathematical algorithm only requires as data source the measurements of electrical barrels. So exclusively we need the measurement of the currents and voltages that we pass inside this mathematical algorithm in order to reach a very precise fault diagnosis and power quality analysis. We place all these results, graphics, trends and tendencies into a web platform that we call ePredict that was created to be user-friendly and to have a seamless layout. So we are able to give you that full picture. I told you that online real-time monitoring that starts in a very simple degradation and continues with the analysis of the level of severity of a fault, but in this case using a completely non-invasive approach. So the innovation comes out from this characteristic, meaning we do not need to place any sensor inside your real assets. In reality, we really do not care where these are located because we just need to have access to the electric room or to the electric board that is supplying these machines. In that sense, we are using a smart algorithm, an algorithm that does not rely on historical data or learning periods, is what we call agnostic to brands, typologies, or to the aging of these real assets. So we are just gathering these currents and voltages into a data acquisition platform in the field, sending it through a gateway to a server where the algorithm will be located, and it will be there that it will be calculating the internal parameters of these machines in order to, in the end, give you a timely, sensitive and reliable fault diagnosis about the operating conditions. We will be able this way to reduce the maintenance costs, the unplanned stoppages, as well as the stoppage time. Remember that we are able to pinpoint the exact location of these faults, increasing your own efficiency in terms of the maintenance decisions and actions. We are working already with completely different business sectors: electrical utilities industry, petrochemical, pulp and paper, cement, nuclear power plants, and water utilities. In this sense, we are already making the monitoring of submerged pumps at this moment. A team of 25 people, as I told you, young, very motivated to help you to take your maintenance to the next level. Thank you.
Okay, very good. So if I'm trying to understand, what you're doing is you're checking the equipment and you can tell from their electric behavior or something, because you say you don't need past data. So how can you not need past data? So what are you detecting? And if you're using agnostic algorithms, usually you need data. So how do you overcome that? I wasn't clear.
That's the innovation of it.
Right.
Yeah. We are reconstructing all the electric waves and we are passing it inside the deterministic mathematical algorithm. This will permit us, obviously, to detect and to pinpoint the exact location of faults that you may have inside the motor or a pump, for instance. So we are able to pinpoint the exact location of that fault or degradation and its evolution, either if it is in the supply side, and we are talking about, for instance, power electronics that can be coupled to that motor, variable speed drives, soft starters, and inside the motor per itself, I will be able to detect if the problem is located in stator, rotor, if it is an eccentricity problem or a mechanical problem or a load problem. All of this by using a very powerful spectral analysis. So the innovation comes from the fact that just going to the electrical board or to the electric room, I will pick up the currents and voltages, be able to translate this electrical waveform into a very powerful spectral analysis, and each spike on that powerful spectral analysis and the amplitude of the same will give me the location and the level of severity.
Okay, I think I understand. But for example, it would not pinpoint the leakage in any way, just the way the electromechanic parts of the utility work. Okay.
We are talking about the operating conditions of a motor or of a pump. If you're having a problem, any sort of degradation, in order to understand when it's going to be the correct timing to perform, I would say, a preventive maintenance, because the main idea is to reduce to the minimum the corrective. So you don't have unplanned stoppages and also reduce the stoppage time of the production process.
All right. Okay. Very good. Anyone else has a question? Artwin, maybe? Coming from the utility? No.
No.
May I ask?
Yes, please, Elena.
Because it was, you mentioned that you have already worked with water utilities in your presentation, but for me it was not clear what would be the benefit of implementing your solution, considering that their number one priority is to identify I think they mentioned the water minimization and the asset management. So how can you support them on these two aspects?
Precisely on the asset management. You have nowadays a problem that in the end, you just go to the field when you have a stoppage, when suddenly the wastewater, for instance, which may consist in a really huge problem, is already stopped. So in this case, you are able to make an online remote and understand when it's going to be the correct timing to perform a preventive outside of the working hours, for instance, of the pump or of the motor, make that preventive so all the system will not stop surely. So the asset optimization, the efficiency, obviously will permit you to maintain all the operating drivetrain of the wastewater or the clean water production, so you can reduce drastically the unplanned stoppages as well as the stoppage time. Obviously, that all of this will be translated into numbers, meaning you will have a much more efficient maintenance action and decision.
All right. I think it's very, very clear. So they would make sure that everything, the
runs as it should
work, and they work well, and they don't.
In a digital way, exactly. Giving maximum.
They don't go out of order before, and they don't surprise you. Yeah.
And it's completely non-invasive. Just to enhance this, that we do not need to go to the real asset itself. It can be underwater, because I just need to go to the electric room where the electric board is located.
Very good, very good, very nice. Okay, I think it's a wrap.
Thank you.
Thank you, and good luck.
Thank you.
Excellent, thank you so much. And now we pass to our last scale-up for today. It's Cosmas Elinas, who is the co-founder and managing director at Nanoplasmas, who will present us their idea, and this session will be followed by 4-minute Q&A.
Hello, my name is Cosmas Elinas, and I'm here to represent Nanoplasmas. In Nanoplasmas, we are trying to address water quality. Currently, all standard microbiological methods take several days to complete. This creates a huge gap between sampling and analysis, and this can cause outbreak of diseases like the Legionnaire disease. To do so, we use a novel technology we have created, and we call it plasma nanotechnology. This technology is protected, the IP of the technology is protected, and it is a platform one, so it can be used in several applications. For our products, we embed it in credit card-like devices like the one you see on your screen, in order to create ultra-fast and ultra-accurate diagnostics. The first product we have invented is the Legionella detection kit. This is a molecular-based technique. It requires no specific equipment, and the result analysis is observed by a single color change, as you can see on the right. More importantly, the results are provided after 70 minutes, so this huge gap is eliminated. The second product, given the COVID-19 crisis, was a detection kit for the detection of the novel coronavirus. In this product, we combine the advantages of rapid tests, which is short analysis time, and the advantages of molecular tests, which is accuracy. So we have a new, more advanced product in the market. With these two products, we focus in 3 market segments. The first is the water analysis, the second is the in vitro diagnostic, and the third is their condition maintenance market. All of them are quite big and grow with a high rate every year. So we believe that our business is sustainable. And it is sustainable because our customers range from facility managers down to public agencies like the problem holder in this case study, and also industries, supermarket, hotels, etc. If we see the competition map, we can see that our product combines all 3 required advantages. It has short analysis time, medium price, and high sensitivity. Nanoplasmas is actually a group of researchers coming from NCSR Demokritos, coupled with some young people working on the company on various aspects. And the short company timeline for us is we launched the company in 2016. Since then, we received 2 venture capital rounds. And nowadays, after having collaborated with several big companies such as Huawei, we are trying to expand in Europe and in Asia through a 3rd investment round. That is all. In this call, we have a complete agreement with the problem holder in order to test our kits, to examine the water quality in their facilities and improve the services they provide to their customers. Of course, we are open to any kind of collaboration, so contact us for a free demonstration of our products. Thank you very much.
Okay, thank you for this presentation. Do you have any questions? Yes, please, Jean-Louis.
Hello again. My question is about, as I understand well, every kit is single-use analysis. Right. So my concern is about the disposal of the product. What I mean is sometimes somehow plastic-free material or environmental, how to say, that is environmentally sustainable also the disposal of the product, because we have a lot of problem here also in Italy with the with the work of all the material, all the text used for COVID, for example, and we are full, and we don't know how to manage it. So it would be a big issue also for new product to be somehow environmental friendly with the disposal, because for the plastic free and something like that. So I want to know your idea about this, and is it possible to achieve it?
My opinion as a co-founder of the company, but also as a researcher in Democritus, working on plastic several years and several modification of plastics, I believe the most efficient way is not only the biodegradable plastics, but also to enable recycling. This is the best solution. For example, there is several companies that say that if the plastics can be used several times. So in our case, our components can be recycled, completely recycled and used again. And we know that for several plastics, there are several cycles that this can be, reusable. So except of using, sometimes more expensive or more exotic biodegradable materials, it is also a good option to check on the recycling and how it goes. So I think in this case, all of the materials, just to address the question about the company, are made from plexiglass, which is completely recyclable and can be used several times. And also the first, and I believe that also the provider of the base material, which we engrave in order to make the microchip, is also using recycled materials. So.
And it is very important because if you are planning also to sell in supermarket, like for example here in Italy that we do, it's difficult to change the society behavior about the material, about the disposal, because they are common to trash everything.
Yeah, you're right. But from our experience in Greece, for example, we had the plastic bags 2 years ago. Everybody was taking 20 plastic bags. Nowadays, I think that the public is more organized to use bags and etc. So I think we should all focus on recycling, and since plastics can be easily recyclable and multiple times, this can be the solution.
Thank you.
Okay, very good. So you measure, you detect Legionella and SARS-CoV-2, but where, in which? Sample? In which sample? Is it in water or is it in?
For the Legionella, it is a water. It can be either water, or you can also take a swab from a container containing water. And in the case of SARS, it is both for human, a separate product which is certified with CE-IVD nowadays. And it is also for environmental testing of air conditioning systems, surfaces, etc. So in the case of bacteria, it is for water or other food-related things. But as I said in my presentation, it is a platform technology, so it can easily be adapted to other bacteria by simply changing the capturing antibody.
And the water utility would take a sample and put it on this little paper. Is that what they would do? And they would do regular sampling.
Can you repeat, because there was an interruption in the signal?
Yeah. So how would the water utility test? They would take a sample and they put it on this little.
Yeah. Actually, if you go back to the slides, you will see that there is a small filter in which you filter the water. All the sample so is minimized, and then is the exact volume required by the microfluidic analysis. So it is, a two-step or three-step, let's say, procedure to do the analysis. And the great advantage is that it has a combination of dual specificity. So you capture the target cell on the antibodies, and then you are doing an isothermal amplification method in order to detect the DNA of the pathogen. So you have this dual specificity that is unique in our case.
All right. They tell me we need to wrap it up. So I hope there was no other question from from you guys. Okay. So, Lydia, back to you. Thank you, and good luck.
Thank you very much. Nice meeting you all.
Yes.
Thank you so much, everyone, for this wonderful pitching session. Now we will proceed to a break. During the break, our jury will have the opportunity to discuss and decide on the two winners, as well as our challenge owner will then announce his final decision about the prize. Thank you all. Stay tuned. We'll be back in half an hour.
All right.
Welcome back, everyone. The moment of celebration finally has arrived. After a little bit longer than we expected, the jury has made its decisions. And before they announce, I would very much like to say thank you for everyone, all the participants. All the pitches were absolutely amazing, and all the questions that you received from the juries really helped the jury to fine-tune their decision and smoothen out any doubt. So all of you are winners, but we only have 3 prizes to allocate today in this competition. So I will give the word to Professor Chrissy Laspidou, who will take the word from the jury's behalf, and she will announce the 2 prizes, and then Thomas will announce the winner of the special prize, the scale-up, who will work with him next year in a demonstration case. So with that, Chrissy.
All right, thank you. It's really nice. I feel like I'm in a show, in a TV show, announcing the winners with a drum roll. Okay, so just to say that we found all of the solutions absolutely, impressive, and it was very difficult to decide. The scores were very, very close to each other. We talked a lot. Each one, I think Thomas also said that at the beginning, if we could combine all of them, we would have the absolute, best solution, because each one, contributed in some way to the problem. So Thomas will specifically talk about what is good for his utility. We gave it a more, generic view using our experience. I will start from the bottom up. Second prize. Let me see, I don't want to be wrong. Okay, so second prize goes to engine. Congratulations. Yes, very good. Applause. Let's all, applaud for that. Yes, there you go. We all agreed that the failure of mechanical and electromechanical equipment anywhere, but also in the water utility, is the cause of huge delays. So you are rightfully the winner, from the bottom up. Thank you for your solution. Congratulations. Okay, now the first winner is Shape. Congratulations, Alex, for this. Yes, applauding. Also, the idea of making easily converting the conventional water meters to digital, and all the other solutions that are friendly, that are quick, that are applicable, could be revolutionary, really, and could, push us in a quick transition towards the data-intensive water management that we all dream of, and all our, algorithms will become applicable. So this is great. Congratulations. And we wish you lots of success from now on. And I want to see a lot more of your solutions applied on the ground. And again, congratulations to all of you. We will probably see you in a different forum, in some project as partners. Thank you for participating. Thank you. This is from us, the jury. Thank you. So follow up, I think Thomas, I think it's you. You're muted. Okay, so how about we give the word, the floor for just a few minutes, just a couple of sentences from the 2 companies that were, awarded the prize. So maybe Walter Sampaio, maybe you can say something from Engine.
Well, first of all, thank you very much. It is a pleasure, and completely motivated, obviously, to continue to address the pain points, specifically these that can address the drivetrain of the water supply. So in this case, thank you very much once again. And it's a real pleasure and a motivation to the team to continue developing these solutions. Thank you very much.
All right, thank you. Thank you. And Alex from Shape, please.
Yeah. Thank you very much. Thank you to all the organizers. And thank you to the juries. Of course, it's always great to see the other solutions and very inspiring. Yeah, I think it's with all our work indeed combined that we'll be able to address water shortages. And I really hope that it will be on the front of the minds of politicians and governments, and that that this will be a top priority for years to come, and as soon as possible, really.
Mm-hmm. Mm-hmm.
So thank you for these kind of events. I think it really helps.
Mm-hmm. Again, congratulations to all of you, and we will see each other soon, I hope. Okay, let's go to the next one from Thomas. Thomas is me.
Okay. I will make a very small introduction. Authorities hearing this, we have a predisposition to solve a problem in a specific manner, even though better or more appropriate methods of solving the problem maybe exist, but in many cases not in very available commercial scale. InnoWise set us in a different path, that of interacting with the solution providers, brainstorming, accepting new challenges, maybe making some pilot plans, maybe an innovation booth for all the participants, but in the direction that we have prioritized our problems here, water leakage detection was on the top priority. So the special prize for a demonstration project goes to FIPSEN. And there are still, as Ramzi Bezurda also mentioned, a long way to cover the last mile. That of interacting with the people, the customers, to get also schools involved. That's also an education aspect of water management. So I think you've said enough already.
Thank you. I'm very so happy.
You should be happy.
Yes. It's an honor to receive this award.
Congratulations to all of you guys. It was really a unique experience for me. Yeah.
Okay, I see myself. Maybe you would like to hear a word from Javier from FIPSEN about his prize and how he feels about it.
I'm feel so happy. It's an honor to receive this award. And we work these months a lot for contribute to the water scarcity, and it's inspiring to connect with this team and the other startups. So thank you for us.
Excellent. Thank you all for being here with us. Congratulations to Saib, Engine, and FIPSEN Monitoring for winning these three prizes. Thank you all for participating. It was a big honor to meeting all these great startups and teams throughout the 3-month process of water scarcity. Many opportunities will come. Thank you all for staying with us, and have a lovely day.